In this example, we are going to find the derivative of the polynomial that's given here. This polynomial, since it's a polynomial, what we have is just a series of terms that are added and subtracted from each other, and each term is a constant times the power of x. And so what we're going to be utilizing is just sums and difference rules, as well as constant multiple rules with power rules. So all of that sounds like a whole lot to swallow when you think about it in the big picture with everything that's happening. But what we're going to do here, just to warm up, is break it down completely. So using a sum and a difference rule, we can take the derivative term by term, where we just take the derivative of the first term there is 2x, and then since a subtraction sign follows, we subtract from it the derivative of the next thing, which is 3, and then a plus sign follows, so we add the derivative of that last term, which is 4x squared. So what we're utilizing there is the sum and difference rule. Okay? So now we've got three things that we need to take the derivative of. Each one of them has a constant that's sitting out front. And so we can use the constant multiple rule to really pull out the constants and then just look here at what's left over. So when we pull out the first one, we pull out a 2 and we're looking at the derivative of x. The next one, if we pull out a 3, we'd be looking at the derivative of 1, which was our starting place. And then the last one, we pull out the constant 4, and we'd be looking at the derivative of x squared. And so what we used here would be the constant multiple rule. Okay? So looking here to finish our derivatives, we see that we need the derivative of x, we need the derivative of 1, and the derivative of x squared. So the derivative of x and the derivative of x squared use the power rule, whereas the derivative of 1 is just our starting place, and we know that to be 0. Okay, so we've got the derivative of x. Now remember that x would have an implied exponent of 1 there. So if we have the exponent of 1 and we want to use the power rule, we bring down the exponent of 1 and we would drop that exponent that's sitting there of 1. We subtract 1 from that exponent. Okay? So moving on to the next term, we've got the constant multiple 3 times the derivative of 1. Derivative of 1 is 0. That was our starting place. And then the last term, we've got 4 times. Now we've got the derivative of x squared. And again, this would be a power rule. So we bring down the power 2, and then the power 2 that's sitting there, we subtract 1 from it. And so what we've used here in this step is the power rule. Okay. So now we've just got to do this algebra here. We've got 2 times x to the 0 power, minus 3 times 0, which is just our 0. And then we've got plus, well, I'll go ahead and put minus 0. And then we've got plus 4 times 2x to the first power. So the 4 times 2 is 8 because we've got associative property, and we can just group the 4 times the 2 together first to get 8. And then we've got the x to the 2 minus 1 is just the first power there. Okay. So what is x to the 0? Well, x to the 0 is 1. Anything non-zero to the 0 power we have is 1. And so we've got 2 times 1, which just would simply be 2, minus the 0, which we're going to drop out, plus 8x. And that would be our derivative. Now that's a lot of writing, that's a lot of details, and as you get extra practice with these problems, you will get to the point where these derivatives of polynomials are just the quickest, simplest ones that you're going to do. You're just going to take the derivative term by term, implicitly using the sum and difference rule. Constants you're just going to leave there because they're not in the way, but you don't have to actually manually pull them out. And then power rules are going to become second nature. And so this sort of problem, even though it's long and drawn out in this example, with practice you'll be able to tackle these sorts of problems super quickly, just term by term, taking the derivative.